Hello all, welcome back to software testing course. So in the last class we had seen about testing levels. So we had seen about unit, then module, integration system, and the last one was acceptance testing. So today we'll get started with the testing approaches. Okay, what are the different approaches you have for testing? So whenever in a large organization you are working, so it is quite impractical to integrate all your submodules in one shot and then you start the testing of the software as whole. So it would create the problems, right? So why? Because whenever say suppose you are working and say for example you have around 70 modules that are coded or constructed, right? So in one shot whenever you integrate all these 70 modules, so you'll end up in a entire software, and testing of that entire software it becomes quite difficult. So it is always better to do a module wise testing, integrate whatever the related modules, do the integration again, and then start testing the software as a whole. Okay, so as it is said, we have to build the system in stages, okay, incrementally. So we need some systematic approach which is easier for debugging. Why? In the sense, whenever in one shot you develop some you develop or integrate entire software, so it is quite difficult for searching of your defects. Even if you find out the defects, it is quite difficult for the developers for debugging. So it is always better to do the testing or the testing in the incremental manner, and then build it also in the incremental manner. Okay, so we will see the testing approaches one by one. So the first one we would be talking is about static versus dynamic testing. So we have already seen this one in the last chapter, right? So what happens in a static testing? So once you have written the code, it is checked without executing. So whatever the code is written, you will not execute it, but you will just go through the code. So this is just a code review kind of thing. Okay, without executing the code, you are gonna check whether the code is correct or not, whether it is working fine or not. So that's why it is also known as desk checking. Okay, so again this static testing can be done formally in a meeting or informally. Like informally in the sense two or more developers or one developer, one tester can sit together and can do this kind of testing, that is desk checking or static testing. Okay, the next one is dynamic testing. So in the dynamic testing, what will happen? The code is executed. That means the program, whatever you have written, it will be executed by giving inputs, and it will be checked for the actual results. Like whether whatever you are expecting, whatever your expected results are same as that of your actual results. So it is advisable to carry out both types of testing. Why? Because each testing reveals specific bugs. For example, if the development team forgot to implement say suppose some functionality or some requirement, so this can be revealed only in the static testing as the code is checked for its completeness. But the dynamic testing, it will not reveal such errors. Fine. So again remember, static means the code is not executed, but it is checked for code completeness. And in the dynamic, code is executed to check whether the expected and the actual results are same or not. Okay. So the second testing approach what you can follow is positive testing versus negative testing. So the software, it has to do what it is intended to do, and it is nothing more and nothing less. So we need to test the software to check whether it is doing what it is supposed to do. That means, say for example, a software, say suppose I would take an example of WhatsApp. Okay, so that is a software. So it is supposed, for example, okay, so WhatsApp is supposed to send messages like single messages, multiple messages at in one go. So this has to happen. So your WhatsApp has to do this task. But that is not enough to test, right? So we also need to check whether it is doing anything which is not it is supposed to do. Say for example, in the WhatsApp only, we had taken the example like in one shot, single message, multiple message has to be sent, right? So same wise, we are in a condition or we are restricting that multiple videos cannot be sent in one go. So this is something like negative. Okay, so your software, it has to do what it is supposed to do, and it should not do nothing more or nothing less. Again, it is not, it should not do some things which is not it is not supposed to do. So this is differentiated by your positive and negative testing. So your positive testing, it ensures that the software will do its task. Suppose whatever it is intended, it is supposed to do, it will do. So that is positive testing. Negative in the sense, it will ensure that it won't do any such task it is not supposed to do. It is quite confusing, but know it, positive and negative testing. Fine? Yeah. The next one is top-down testing versus bottom-up testing. So in the top-down approach, the testing is done from top of the hierarchy, right? For top-down testing, we will be making use of dummy routines called as stubs. And in the bottom-up approach, what will happen is testing would be done from the bottom of the hierarchy. So the dummy routines called as drivers would be introduced that would invoke a module in the bottom-up approach. So we will take an example. So for example, say you have a software that implements the stack. Okay, stack has push and pop operation, right? So the program, it contains a main function and the function, two functions, push and pop. So whenever you are making use of top down approach, first the main function is tested. Okay, for this, in place of your push and pop function, what you do is like you just write a function, dummy function. Okay, so in that dummy function, you'll just have a statement called as printf, just printf statements. So that printf statement says this is push function, and for pop it says pop function. Okay, so again, in the main function, you will be writing the main function in the top down approach, right? So that main function, it contains or it has the function calls but not the function definition. Okay, so wherever we have created dummy function definitions, those things we call it as stubs. So in the bottom approach, what will happen? You have the driver function first. That means driver functions or the dummy functions called as dummy routines called as drivers, right? So those driver functions are nothing but the actual push operation and pop operation, but you will not be having the main function. So what you do is like first you test the push function, then you test the pop function. Okay, so what will happen now is drivers are such thing that drivers are similar to your function definition. Okay, so whenever you have bottom up approach, you have the function definition but you will not be having the function call. Okay, but in the top down testing, what will happen? You'll be having the function call but you'll not be having the function definition. So this is top down and bottom up approach. So at the system level, whenever you are doing the entire system testing, to carry out the top-down approach is quite difficult, so it is always better to use your bottom-up approach. That means test the sub-modules first, then the subsystems, and then the system as a whole. Okay. Next is functional testing versus structural testing. So in the functional testing, we check for what the software is doing or what the software does. That means the functionality of the modules that would be tested, but we will not consider the structure in the sense the code, how it is written. So that's why we call this functional testing as black box testing. That means the test cases, whatever you write for testing the system, that would be based on your specifications, based on the SRS, whatever the functionality is there, you will be making use of that and you would be writing test cases. But here you will not consider the internals of the modules, like what data structure is used, how it is done. We are not bothering about the internal structure in the functional testing. So this functional testing, it is also called as black box testing. Okay. The structure of the program, it differs at different levels. At the component level or at the unit level, the structure is your code. At the integration level, the structure is a tree diagram that shows the interconnecting of your submodules. And at the system level, it is a menu kind of structures or web page structure, right? And or your business process depending on your application. Now this structure of the testing or structural testing, we also called it as white box testing, or it is also called as clear box testing, or it is also called as glass box testing. Okay, so next we will talk about the structural testing. So structural testing at the component level, it is used to test the implementation of the program, the coding. Okay, here the source code is looked into for the testing of the software. Now your structural testing, it involves statement coverage, condition coverage and path coverage. This comes for your code. Okay, structural testing means white box testing, basically the coding is involved here. So first one is statement coverage. So this ensures that each and every statement is executed in your code. So it is advisable to ensure that every line of code is executed at least once. So if you have written a code which contains 5000 lines of code, so in the statement coverage you have to ensure that each or all the 5000 lines of code, whatever you have written, it is executed at least once. Okay, so but how can you test it manually? It is quite difficult, right, to test. If suppose you have a program of 10 lines, 50 lines, it is that time it is easy to check manually, but you have 1000 lines of codes and you have to check whether it is executing or not manually. That too, it is quite difficult. For that purpose we have some tools to check this one, whether the lines of code, the code whatever you have written, it is executed, it executes at least once or not. So that one particular or one such tool is like your called as profilers. Okay, these profilers used to carry out this statement coverage testing. It is a tool, profilers is a tool that will test whether whatever, how many number of say any number of code you have written or lines of code you have written, this profiler tool will check whether those lines of codes are executed at least once or not. Okay, it indicates the number of times each line in the code is executed. This is the work of your profiler. Again, your profiler, it will also tell you which code or the line number which has not been executed. So after studying the output of the profiler, you can create new test cases that execute the earlier ones which were undetected. Undetected in the sense that were not executed. So those, for those lines of code, you can write the test cases. So the next one is condition coverage. So here what will happen is each and every branch operation or every condition, it is taken into consideration and inputs are given in a such way that each condition or a branch is executed at least once. For example, you can see here, if A is greater than 6 and B is less than 5, then execute some statements, else execute some other statements, right? So here it has to be certainly ensured that both this then and else statements are executed at least once. So the test cases are chosen such a way that the condition becomes true, then the statements are executed. If it becomes, the condition becomes false, some other test case is executed. Okay, that means your else part would be executed. So in addition to this one, it is also necessary to ensure that each individual condition in the conditional statement, it is made true and false. That is, if a is greater than 6, it is true, and it has to make you have to write test cases for making that condition false, like a is not greater than 6. The next condition is b is less than 5. You have to test for this condition, as well as b is greater than 5. You have to test for that condition as well. So you have a formula for this condition coverage in percentage, that is number of conditions executed divided by total number of conditions into 100, that gives you the condition coverage percentage. Okay, the next one is path coverage. So in path coverage, it is ensured that each path is executed at least once. In your flow diagram or flow chart, each path we have to make sure it is executed at least once. So you can convert the given program into either flow chart, and you will know pictorially how many paths are possible. So you need to design test cases to ensure that each path is executed at least once. So for example, consider this flow chart here and its corresponding flow path. Okay, so hence test cases need to be formulated to ensure that each path is tested at least once. So we have to note here that the path coverage, it deals with the logical paths in the program. So for small programs, the path coverage can be easily ensured by designing the necessary test cases. Okay. And however, but in your practical systems with millions lines of code, 100% path coverage is not easy. Okay. So as you can see in the diagram, this is your flow chart, right? So calculate how many paths are possible for here, for this diagram. So you want to find D, right? So this is for quadratic equation. Whenever D is greater than 0, it is real root, one path. If it is less than 0, the other path, two paths are there, right? So to calculate path coverage also we have a formula, that is number of paths executed divided by whatever the total number of paths we have calculated into 100. Okay. So next is function coverage. So in the function coverage, it is ensured that each and every function is called at least once. I have given you the example of a stack, right, wherein we had push and pop operation. We had only two operations there. So we have to ensure that that push is called at least once and the pop operation is called at least once. So this is the function coverage. So this ensures that all the functions in your program are tested. This comes into picture just for two functions. It is very easy, but you have many functions. That time it would be quite difficult. You might end up in having duplicate functions or writing the function definition but not calling it. This kind of thing can happen. So developing the test cases for function coverage is quite easy than compared to your developing test cases for path coverage and condition coverage. That's it for today. We'll conclude our session. Thank you.